This short lesson looks at interval notation again and looks at how we can represent intersection and union of sets that are done as intervals. And remember that intervals are only used for real numbers. We need to use set notation if we're going to use any of the other number sets. Okay, so if our instructions are to find the intersection or union of two intervals, then the first step is to graph each interval on a number line, and I'll show you a quick and easy way of doing that. And then step 2, for the intersection, you're only taking the part that they have in common, because remember, intersection by definition is only the portion of the set that is common to both. And number 3, step 3, if it's a union, use the total collection of the numbers. So here are the instructions. Use graphs to find each set. Express your answer in interval notation and in set notation. And that's really to give us the practice with using set notation as well, which is a little trickier. So here's our first example. We've got the intersection of the interval 2 to 7 and the interval 3 to 10. So to graph those, it's best to have, we want our answer showing up on the number line. So show these two intervals floating above the number line instead. So if I do the 2 and 7, I'm going to float them above the number line. So I'm going from 2 to 7. Still want to be as precise as possible, and using a ruler would be a really nice way to do this. And I've got the interval 3 to 10 with square brackets. So I'll float that one here, 3 to 10. Okay, and since it's an intersection, I'm only using the portion that those two have in common, which starts here at the 3 and includes the 3 on both of these lines. Okay, here and here, there's the 3, and ends at 7. The 7's included on the lower line, but not on the upper line, because that round bracket means 7's not included. So that means we'll need to use a round bracket at the 7, and we can use a square bracket at the 3, and there's our solution. This is the intersection set. So we could write that intersection now as square bracket 3 to 7 with a round bracket at that end. Or we could write it using set notation. It's the set of all x such that, and remember we start low and go high, so we're starting at 3, x is in the middle, and it ends at 7. And we always use the less than and sometimes use less than or equal. So it can be equal to 3, so less than or equal to 3 and less than 7, but not equal to 7. Okay, so there's the set notation version. Okay, so let's try another one. We've got the interval 3, 7 united with, or the union of the intervals 3, 7, and 4, 12. So again, we'll float them above. So 3 to 7 with round brackets. And 4 has a round bracket as well. And 12 has a square bracket. Okay, and a union means everything that's in one set or the other set or both. So really our solution, our final one, is going to go right from the very lowest number to the very highest number. So it's going to start at 3, but still with a round bracket, and it's going to end at 12 with a square bracket. And there's our solution set. And so that gives us round bracket 3, square bracket 12. Okay, so we've shown it on the graph, we've shown it using interval notation, and for practice we'll also put it in set notation. It's the set of all x such that, and our low is 3, our high is 12, x is all the values between, and we use less than, and wherever there's a square bracket we add the equals to the less than symbol. Okay, let's look at a couple more examples, or feel free to start in on the work if you feel comfortable with it. So in this example, we're doing intersection again. So again, it's only the part that's on both, and we're going from -2 to 1 with square brackets. -2 to 1 with square, and from -1 to 4, the -1 is round though, and the 4 is square. So the intersection, the part that's common to both, will be starting at the -1, but only round because -1 itself is not included in the second interval. And it'll end at 1, but with a square bracket since -1 is common to both. So that is the graph. We can write that as an interval, round bracket, -1 to 1 with a square bracket. Or using set notation, it's the set of all x such that, and we're going from -1, x is in between -1 and 1, close the set, less than or equal to, because we've got a square bracket there, and just less than in the other case. Okay, and one more example, which is a union again, so we'll take everything. We're going from 1 to 7, so 1 to 7, including 7. And we're going from 3 to 6. And just with round brackets. Okay, so because it's the union, it's everything that either one covers. So really you can see that the solution is actually the same as the first interval because the second interval is completely contained within the first interval. So our solution set is actually from 1 to 7 with a square bracket. And again, in set notation, it's the set of all x such that 1 is less than x, which is less than or equal to 7. And that's it. So some people, a lot of people, are able to look at the two intervals and decide what the solution is by visualizing it. But this is a quick way using the graph to see what the intervals are and to see which part is either the overlap or the entire solution. Also, very good to practice the set notation here so that you feel comfortable reading it and understanding it as well as writing it. I strongly suggest you speak it out loud when you're doing set notation.